The National Electrical Code, specifically Table 250.66, addresses the sizing of the grounding electrode conductor. When using ground rods as the grounding electrode, there's a specific provision outlined in 250.66 that addresses conductor sizing. The code allows for a reduction in size for a specific portion of the grounding electrode conductor. This portion is defined as the segment that serves as the sole connection to the grounding electrode, which in this case is the ground rod. The code states that this particular segment of the conductor is not required to be larger than a number 4 aluminum conductor. This provision does not mean that the entire grounding electrode conductor can be reduced to a number 4 aluminum, nor does it imply that you should reduce or haircut a larger conductor to a number 4 aluminum along its entire length. The code permits a splice within the grounding electrode conductor. The section of the conductor that runs from the electrical panel to the point where its splice can be sized according to the full requirements of Table 250.66, which in the scenario indicates a 3/0 aluminum conductor. However, a portion of the conductor that extends from the splice to the actual ground rod electrode can be a smaller size, specifically a number 4 aluminum conductor. The rationale behind this allowance stems from the characteristics of ground rods as conductors. Ground rods, while serving an important function in the grounding system, are not highly efficient conductors. Because of this limitation, the code recognizes that using a large conductor size directly connected to the ground rod provides minimal additional benefit. Therefore, it permits the use of a smaller conductor size, such as number 4 aluminum, for that final connection to the ground rod. To implement this correctly, you would typically run a 3/0 aluminum grounding electrode conductor from the main electrical panel to a point near the ground rod. At that location, you would create a suitable splice, ensuring a proper and listed connection method is used. From that splice, you would then run a number 4 aluminum conductor to the ground rod, completing the connection. It's crucial to use listed connectors approved for the specific conductor materials and sizes being joined, for example, connecting the 3/0 aluminum conductor to the number 4 aluminum conductor. Also, ensure the connection to the ground rod itself is made with a listed grounding clamp suitable for direct burial. Splicing the grounding electrode conductor and reducing the size only for the final connection to the ground rod is permitted under specific conditions outlined by the NEC. Remember these key points. Firstly, Table 250.66 dictates the size of the grounding electrode conductor based on the size of the service entrance conductors or equivalent for a separately derived system. Secondly, 250.66 allows for a reduced size for the portion of the grounding electrode conductor that is the sole connection to a ground rod, pipe, or plate electrode, but not smaller than number 6 copper or number 4 aluminum. Thirdly, this exception only applies to the section of the conductor making the direct connection to the electrode. The remainder of the grounding electrode conductor must be sized according to Table 250.66. Fourthly, proper splicing techniques and listed connectors are essential for a safe and effective grounding system. Here's a breakdown of the grounding electrode conductor requirements for different grounding electrodes. Firstly, for ground rods and pipes, the portion of the grounding electrode conductor serving as the sole connection to the electrode doesn't need to be larger than number 6 copper or number 4 aluminum. Secondly, for concrete encased electrodes, the grounding electrode conductor doesn't need to be larger than number 4 copper. Thirdly, for ground rings, the grounding electrode conductor doesn't need to be larger than the ring conductor itself. When dealing with multiple grounding electrodes that are bonded together, the size of the bonding jumper is addressed in 250.64f. The bonding jumper must not be smaller than the largest grounding electrode conductor. Grounding electrode conductors must be connected to the grounding electrode in a manner that ensures a permanent and effective ground path. The connection method must be suitable for the materials of the grounding electrode and the conductor, and it must be listed for the purpose. In general, the grounding electrode conductor should be run in a straight line as possible, avoiding sharp bends or unnecessary lengths. This helps to minimize impedance and ensure effective grounding. Remember to consult the latest edition of the National Electrical Code for the most up-to-date requirements, and always follow local codes and regulations. The grounding electrode conductor is sized based on the size of the service entrance conductors. According to NEC Table 250.66, for a 400 amp service with aluminum service entrance conductors, a 3/0 aluminum grounding electrode conductor is typically required. However, 250.66 provides an exception for ground rod connections. It states that the portion of the grounding electrode conductor that is the sole connection to the ground rod does not need to be larger than number 4 aluminum. This means you can splice the 3/0 aluminum grounding electrode conductor and run a number 4 aluminum conductor from the splice to the ground rod. The purpose of this exception is that ground rods are not very good conductors, so there is no need to use a large conductor size for this portion of the connection. To summarize, run a 3/0 aluminum grounding electrode conductor from the panel to a point near the ground rod. Then splice the 3/0 aluminum grounding electrode conductor to a number 4 aluminum conductor. Finally, run the number 4 aluminum conductor from the splice to the ground rod. Make sure to use listed connectors approved for the specific conductor materials and sizes being joined. Grounding systems play a critical role in electrical safety. Grounding ensures that metallic parts of an electrical system that could become energized due to a fault are connected to earth. This connection provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. The grounding electrode system consists of various components that are interconnected to form a comprehensive grounding network. These components include the grounding electrode conductor, grounding electrodes, bonding jumpers, and the equipment grounding conductors. The grounding electrode conductor connects the electrical system's grounded conductor, usually the neutral, to the grounding electrode. The grounding electrode is a conductive object that is buried in the earth and provides a direct connection to ground. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipes. Bonding jumpers are used to connect different metallic parts of the electrical system together, ensuring that they are all at the same electrical potential. This helps to prevent voltage differences that could create a shock hazard. Equipment grounding conductors provide a path for fault current to flow back to the source from the metallic enclosures of electrical equipment. This helps to trip the overcurrent protection device in the event of a fault. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. The grounding electrode conductor must be large enough to safely carry the maximum fault current that could be imposed on it. The grounding electrode must be installed in accordance with NEC requirements. Ground rods must be driven at least 8 feet into the ground and must be located at least 6 feet apart. Ground plates must have a surface area of at least 2 square feet and must be buried below the permanent moisture level. Underground metallic water pipes must be used as grounding electrodes only if they are in direct contact with the earth for at least 10 feet. Bonding jumpers must be sized according to NEC Table 250.102, based on the size of the largest ungrounded conductor in the circuit. Bonding jumpers must be installed in a manner that ensures a permanent and effective connection. Equipment grounding conductors must be sized according to NEC Table 250.122, based on the rating of the overcurrent protection device protecting the circuit. Equipment grounding conductors must be installed in the same raceway or cable as the circuit conductors. Here's some important considerations for grounding and bonding. Firstly, all metallic parts of the electrical system that could become energized must be grounded. Secondly, the grounding system must be installed in accordance with NEC requirements. Thirdly, the grounding system must be properly maintained to ensure its effectiveness. Fourthly, any modifications or repairs to the electrical system must be made in a manner that maintains the integrity of the grounding system. The purpose of the grounding electrode system is to provide a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. This helps to protect people from electrical shock and to prevent damage to equipment.